Alright guys, the next couple of videos are going to look at more interesting substitutions. And so we've got a little table over here that we're going to be looking at today, but let me just present one situation to you. So I got the integral of x times the root of x plus 3. Now you may say, oh well, I can do that. I just make u equal to x plus 3 and du equals 1, and so then you try to put it in, you go integral of x times u to the 1/2, and then the dx, that was du dx, and so then we can put du in for dx, and of course the problem is this, that you still have x and u in there. Okay, now that's actually not a bad idea to make x plus 3u, but you're going to have to do a little bit more. Okay, so in addition to what we've done here, you're going to need to put something in for x. And so if u is x plus 3, that means that x equals u minus 3. And so we're going to go ahead and put that in. So we're going to have the integral of u minus 3 times u to the 1/2 du. And so now we've solved the issue about having both x and u, and we can go ahead and distribute the u to the 1/2, which will make this u to the 3/2 minus 3u to the 1/2 du. And so this is this first one right here where we did make f of x u, but we had to make that slight adjustment of then putting in for x. And so then we've got u to the 5/2 times 2/5 minus, and then 1/2 will give me u to the 3/2, and if I put the 2/3 in front, 2/3 times 3 is just going to be 2, and then of course your plus c, and then when we put u back in, we're going to have 2/5 times x plus 3 to the 5/2 minus 2 times x plus 3 to the 3/2 plus c. So there you go. There's a way to be able to do it even if it doesn't look like at first chance that it's going to work out. Okay, now actually what I want to do is show you another way that you possibly could have done this. And here it says try making the square root of f of x. Try making f of x u. What if we make the square root of f of x u? So instead of this, we're going to say u equals the square root of x plus 3. Alright, now I know that seems a little bit weird, but let's just do the same thing. We know that we're going to have to eventually substitute for x anyway, so we'll go ahead and do that. We'll rearrange, we'll square both sides, so I'm going to have u squared minus 3 equals x. Alright, and then the other thing that we need is we need dx du, so we'll take the derivative of x with respect to u. So dx du equals 2u. Alright, so this can be rewritten. We put the du over there, so dx equals 2u du. And so now we can put everything back into our original integral. So we just go integral of x, but instead of x, I'm going to put u squared minus 3. And then the square root of x plus 3, which was u. And then for the dx, I'm going to put in 2u du. So 2u du. Now if I multiply all that out, because it still looks a little bit like a mess, but if I distribute everything, this will be 2u squared. So I'll have 2u to the 4th, and then minus 6u squared du. And that I can actually take the integral of. And so I'm going to have the integral. So I'm going to have 2u to the 5th, but if I put the u to the 5th, then I've got to put the 1/5 in front, minus 6u to the 3rd, but because of the 3rd, I've got to put a 1/3 in front, and then the plus c. And so I can put u back in, simplify this a little bit, so I'm going to have 2/5 times u, which is the square root of x plus 3, to the 5th, minus 2 times the square root of x plus 3 to the 3rd plus c, and you'll notice that this is exactly the same thing as we had over there. 2/5 of x plus 3 to the 5/2 minus 2 times x plus 3 to the 3/2 plus c. What? Anyway, so that's my first interesting substitution. Watch the next one, and I'll give you another one.